Okay, good. Ignore the sound on the roof. That's only hurricane. Nice little rain. Somebody's got a question. Hang on a second. Okay, now let me point out, I'm going to say this kind of quickly. If you don't know what a type 1, type 2, or type 3 graph is, the very first class, their videos. There's a 6-minute video on the type 3 graph. I also did it in maybe 2 minutes at the end of the video that I posted for last Thursday, the one I did yesterday at Sound, okay? So if you can get it from the end of that video, which I think most of you can, fine, but you're responsible for knowing how to do a type 3 graph, okay? I mean, I did it last Thursday, but you didn't have the video for reference, so you might have not taken good notes or whatever. I just thought, well, I'll look at the video and get the details later, whatever. Type 1 and type 2 graphs, I also have separate videos showing how to construct these things. And really showing it, and I'll say this for benefit of anybody. Okay, if you take this piece of paper, I can fold this. And that crease right there is halfway between the left and right edge, right? And right down here is the red dot if you're doing a type 1 or type 2 graph. You have to know where the red dot is. A lot of people didn't seem to know where the red dot is, and take a lesson and make sure you know the details. Because I gave you those details last week, okay? And I think I gave you those details on the first day for the type 1 graph. But anyhow, that's where the red dot is for a type 1 or type 2 graph. Now, if I want to do a type 1 graph for vertical lines, I take the left edge, well, that's the right edge from your point of view, and fold it over to the middle and make a crease. And then I take the right edge and fold it over to the middle, the left edge as you see it, and make a crease. And there you see my vertical lines for type 1 graph, right? Then I want a line halfway between here and here to get a type 2 graph, and halfway between here and here. In other words, I've gone from the middle, from the edge to the middle. I've done a line halfway. I want a line halfway from there to the middle. So I take this crease and fold it over to the middle, which is a little tough to do. It'd be easier if I had a table in front of me. But with my incredible dexterity, I think I managed it. Okay. So now we have this side, and on this side, we do the same thing, but I'm not going to do it. It takes too long. Then I can fold it vertically, or fold it about a horizontal line. It's already creased, so it's a little more difficult. It's not cooperating, but incredible dexterity wins again. Okay. So, well, now I've got my horizontal line in the middle, right? Then I can bring the lower edge up to there and get the line halfway from lower edge to the middle. Bring the lower edge down, bring it up to that last line, fold it again, and fold it again. If you do more than 5 folds, you must be using tools. This paper gets pretty obstinate, but that's the idea of a type 1 or a type 2 graph. In a type 1 or type 2 graph, or actually in, even in a type 3 graph. Now, for a type 3 graph, you do this. You fold it just like you did here. So I'm not going to talk about that, but use exactly the same rule, but with horizontal lines. It's in the video. And you'll see some paper folding in the video, so I wanted to demonstrate that. Now, not everybody needs to look at the video because most of you do pretty well with these graphs, but I'm going to refer to paper folding when I do this. I'm going to construct the exponential shape. Now, when you say construct the exponential shape, you don't put numbers on it. No numbers. Then we say, okay, it's a 4x4 rectangle with the red dot at 1, 0. Okay? But we construct the shape without thinking about any numbers. We just fold the dang paper. Okay? So we fold the paper once, we get this crease. Fold the paper again, we get this crease. Fold it again, we get this one. There we have it. That's everything we do for an exponential shape. That's a type 1 graph. If we do another one between here and here, and another one between here and here, that's what we do for a type 2 graph or a type 3 graph. Okay. Now we do a fold down the middle to the horizontal line. And for an exponential shape, okay, that line is halfway between the upper edge and the lower edge, right? Then halfway between that line and the lower edge is here. And halfway between that line and the lower edge is here. And halfway between that line and the lower edge is here, and there's our grid. Okay? We're just going halfway to the lower edge each time. Then we sketch our points. And the rule is you start at the left edge on the lowest construction line. These things are construction lines. These are boundary lines. The lowest construction line is here. And the first point goes here. It doesn't go here. Okay? And there's a temptation to want to put it in that lower edge. Right there in that lower corner. It doesn't go there. So you want to be careful about that, because now if you go over one line, up one line, 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 you get a pretty clear shape, and you can sketch a curve. And that's your exponential shape. Now you can make the rectangle higher or lower or wider, squash it down, but make it big enough that you can make estimates. Don't make a little tiny graph if you're going to make estimates. Okay? And I don't think anybody, I think that all the graphs I saw were of very decent size. Okay? The bigger your graph, the better your estimates. And the more careful you are with these lines, but if you're even halfway careful, you're going to get a pretty good representation. Practice until you can do that. Draw this thing. Because I'm going to ask you to draw these things almost every day in class. You're going to draw one of these. And I'm not going to give you 5 minutes to do it. Okay? About a minute. So be sure you get these things down where you draw them in a minute. It does not take that long. Okay. And that's simply so we can have class time to actually use the things. Now, we want to label it with a scale. It's 4x4 rectangle. Means it's 4 units wide. It's 4 units high. And I've said this before, so I'm saying it. It's 4 here, and it's 4 here. The red dot, and actually I shouldn't be putting numbers on it until I draw the red dot. It's at the midpoint of the lowest line, of the bottom edge. Okay? And that means that this thing is at y equals 0, meaning this horizontal line is the line y equals 0. This bottom edge is on the line y equals 0. The top edge is 4 units higher, so that's y equals 4. Now, halfway between 0 and 4 is this line, and you know that halfway between 0 and 4 is, what is it, 3? Oh, 2. Thank you. Okay, y equals 2. Okay, and halfway between 0 and 2, I'm not going to ask you to show me that one with your fingers because I'm a little worried about which finger you use. Y equals 1. Okay, make sense? Okay, and halfway between 0 and 1 is 1/2. And halfway between 0 and 1/2 is 1/4. So now we can label our x's. Now, x equals 1 at the red dot, so this vertical line is x equals 1. The width of this thing is 4 units. This is in the middle of the lower edge, so that this distance is 2. Distance from the middle to the right edge is 2. So here's x equals 3 because from 1 to 3 is 2 units, right? And if we go to the left 2 units from x equals 1, we're going to get x equals -1. And then halfway between 1 and 3 is this line, that's x equals 2. And halfway between -1 and 1 is x equals 0. So if you're going to draw x and y axes, the origin would be right here. The x-axis would be up here, y-axis would be here, but we're not drawing x and y axes yet. Yeah, you will for homework. Okay, so we want to get this process down. Now notice, I used no numbers to sketch this graph, and it's a much better graph than you would do by hand if you were to do what open math says, okay? Which is, they give you the function and tell you to make a table. Well, that's good. Now we've already seen the function for this graph, okay? For the toolkit graph, this line is x equals 0, this is -2, this is +2. And the toolkit function, and you're gonna maybe have to review a little bit, but the toolkit function is the same graph. It's a 4x4 exponential shape with the red dots at 0, 0. Okay? And that's the function y equals 2 raised to the x power, as we've talked about Thursday and Tuesday, although you couldn't hear me if you were relying on the video. Okay? It's in there, and then one advantage, the video that I made yesterday is a little shorter. But then there's a lot of stuff I said Thursday that I wish I'd have thought to say yesterday. Okay, so there's lots. I'm really pretty bummed about it, but got to go on. Okay, so toolkit function y equals 2 to the x. It's this. Now that's not this function because this function has a red dot at 1, 0. So this function, and we saw last time, if we put it at 2, 0, it's y to the x minus 2. Remember that? Okay. Now, you remember it from class, because again, you wouldn't have been able to hear it in the video. And I really think it's not the microphone. I think it's the docking station. Because when we unplugged it from the docking station, plugged it into the computer, it started working. But then we plugged it back into the docking station and it worked. So maybe it just wanted to be unplugged and plugged in. I don't know. I didn't take time to do any extensive testing. I just went out and spent $100. Okay. Because it was worth the aggravation. Plus, I'm getting a nice camera that I can use elsewhere. Okay. And hopefully it'll work here. Okay, well, back to reality. Here's your toolkit function, y equals 2 to the x. This function is two to the x minus 1. Now I got to do this really briefly because there's a lot of other stuff we need to talk about. But if I make a table, the x coordinates of these points are -1, 1, 0, 1, 2, 3. You can see that right along the bottom. The y coordinates are 1/4, 1/2, 1, 2, and 4. So we've done this in more detail. Now, these are the same y values you get if you draw the 4x4 exponential with the red dot at 0, 0. Okay? It's a 4x4 rectangle, and the red dot has y coordinate 0, you're always going to get these numbers. Okay? But these numbers can be calculated. Now, last Thursday, we calculated the numbers for 2 to the x. And we talked about negative exponents and all that stuff. Again, if you're relying on the videos, you get to hear it. But the rules are fairly simple. So I'm going to do the calculations. Okay, 2 to the x minus 1 would be 2 to the -1 minus 1, which is 2 to the -2nd power, which is 1 over 2 to the 2nd power, which, lo and behold, is 1/4. This calculation with this function totally agrees with what we know from reality, which is a construction without any mathematics on it, except halfway. It's the only math you got to know to do that construction, halfway. Okay, when x is 0, well, 2 to the x minus 1 would be 2 to the 0 minus 1, which is 2 to the -1, which is 1 over 2 to the 1, which is 1/2. When x is 1, you get 2 to the 1 minus 1, which is 2 to the 0, which is not 0, it's 1. And we showed why that is by descending powers of 2 in the whole thing. And that's on a video that I posted somewhere last time. I could check the site, but I don't want to take the time. It's up there for either Thursday or Tuesday. Okay. Then when x equals 2, we put in 2, we get 2 to 2 minus 1, which is 2 to 1, which is 2. And then 2 to the 3 minus 1, which is 2 to the 2nd, which is 4. And these numbers exactly match these numbers that we got before we knew anything about numbers. Okay? And that should be kind of astounding if you think about it, but maybe not. That's the process. The other graphs are equally straightforward to construct if you know the rules and practice them and can draw them quickly when needed. And these graphs are what we hang most of the understanding of functions on. These are the graphs we use, plus a couple of others, to build the functions that we do calculus with and more advanced mathematics. And also underlies the mathematics and statistics. Okay. All right. Now we want to get to the question of, I gave this graph a meaning. X is a time in decades and Y is a value in dollars. Maybe it's an investment at a constant interest rate. Okay, be an interest rate that'd be an interest rate of about 7%. It's good luck if you get that. Okay. What I want to then ask is, how do we approximate the value when x equals 2.3. Now, what does x equals 2.3 mean here? It means after 2.3 decades, or at the 2.3 decade mark. Now, this means, if this means today at x equals 0, this means 10 years ago, a decade ago, right? This means 10 years in the future, 20 years, 30 years in the future. 30 years in the future, most of y'all still be young, from my perspective. Okay, some may be getting a little crotchety, but you know, comes with age. I don't know if you heard what I said to Maritza, but I learned about 14, 16, 18 days ago, if you're doing a set of decline presses and you reach failure and you know you're not going to be able to do the next one, don't try to do the next one. Okay. In other words, as you get older, be smarter than I was. Been doing it all my life. Okay, with less weight than you used to be, but pretty much didn't mess it up as bad as I thought, but it's going to take a while. Now, let's see, back here, just talking about decades, okay? 3 decades seems like a pretty short time to me. Seems like a pretty long time to most of you. Okay. What's this mean? Like, what does this point tell you? It says that after 2 decades, the value, oh, I said value in dollars, it's only worth $2. I'm going to change that. I meant to write thousands. And even that's not, I could say tens of thousands, but I don't have room to write it in. Okay, or millions. Okay, yeah, because most of you are dealing in billions, right? Okay, well, hopefully someday. So this tells me that after 2 decades, I'll have $2,000. And after 3 decades, I'll have $4,000. It's probably about enough to buy a loaf of bread in 2055. Okay. Hopefully keep things stable. Okay. So anyhow, how much did you invest today in order to have $4,000 30 years in the future? Well, today is at x equals 0. There's the x equals 0 point, right? How many dollars is that? Well, that's $1,000. That's 500 bucks. Okay. That means your money be worth 8 times as much. At least the dollar value be 8 times as much. We don't know what it's going to be worth. So my question is, when x equals 2.3, what's the value of y? How are you going to do that? Well, I'll show you. Some of you figured it out. It means x is between 2 and 3 and closer to 2. Is that a reasonable line for x equals 2.3? It's not unreasonable. I think it's a little too far to the right. It's kind of slanting back a little bit. It's still, yeah, that's about 2.35 or so. Anyhow, there it is. Okay. So how are you going to figure out what the value is? Well, when x equals 2.3, this point on the graph tells you that its value is whatever y is here. Okay. So y equals what at this point? Well, it's between 2 and 4. It's closer to 2. And it could be helpful to draw a line halfway between 2 and 4, which would be right about here. You don't need it to construct the graph, but if you're going to make estimates, you draw any lines that you think you can draw pretty accurately and base your estimates. Now, this looks like it's between 2 and 3, about halfway. Over here, it looks a little low, but there it looks about halfway. So I can say y equals 2.5. Okay. Now, this is a function y equals 2 to the x minus 1. How many of you have a calculator handy? You got your phone, you probably have a calculator on it. So if you got something with a calculator, pull it out and substitute x equals 2.3 into this function. Okay, so I'm going to say over here, for estimate, for x equals 2.3 is y approximately equal to 2.5. This little wave in the equal sign means it's approximate. Oh, wait a minute. Yeah, that's right. If x equals 2.3, y equals 2 to the x minus 5 equals 2 to the 2.3 minus 1, which is 2 raised to the 1.3 power. Now, on your calculator, can you do 2 raised to the 1.3 power? Anybody got that? Hang on a minute. Look at the time. We've got half hour or so left. So I'm just trying to, how much we can do there. Okay, you're going to talk back to me? I don't want to hear it. Okay. Now, oh, geez, I was recording that. Okay, well, whatever. What did this tell you about the situation? It tells you that after 2.3 decades, which is 23 years down the road, your $500 that you invest at x equals 0 times 0 will have grown as much. So there's meaning to these graphs. Now I'll show you a meaning every day, so you have some idea why we're even doing this. But that should strike you. Okay. what I ultimately want you to be able to do is what we did Tuesday. I tell you what size the window is and where the red dot is. And which graph, which function. Okay? And then you do estimates. Think you can handle that? There's going to be a test next week that asks you to do that and a couple of other things. Okay? Okay, so I'm going to do another example. I'm going to do a quadratic function. Quadratic shape, 12 by 4. Red dot at the point 16, 8. Okay. The grid, which you should be able to draw really quickly, but I want to get it down quickly. You know, we divide it here, we divide it here, we divide it here, and then we divide it here and here. Everything's a halfway. Then we go down the middle, halfway from there to the lower edge, halfway from there to the lower edge, halfway from there to the lower edge, and halfway from there to the lower edge. 5 lines here. So 5 times we go, start up here, go to the lower edge. That's the first time. Second time from that line to the lower edge. So you have 5 lines there, 5 construction lines. Then the rule is start in the upper left-hand corner, move 1 to the right and 2 down. And before you do that, put the red dot on this thing. And note that that is at the point. Get the chalk right, 16, 8. Okay. Upper corner, over 1, down 2, over 1, down 2, over 1, down 2, which puts you in the red dot. Then over 1, up 2, over 1, up 2, over 1, up 2. So that the graph is completely symmetric from left to right. And you sketch the curve, which is called a parabola. Fair enough? Then you put the numbers on it. So go ahead and put the numbers on it. I'll just come around and see how you're doing. We'll give you a few. Okay, and now I'm going to say, last time we did 8 by 4, right? I would think that in your notes, just as a suggestion, not telling you did something bad or wrong or anything, but in the future, you know, it's kind of important to know which one's the 8 and which one's the 4, isn't it? Because that's the kind of thing that's really easy to mix up. So when we did it, if you just drew a picture like this that said 4 here and 8 here, and you know, but if you get that note in your notebook, you look back and see it, unless we do. For a quiz, if I'd have had a 12 by 4, I'd have said, remember that's 12 high. But here I just laid it on you. So some people did a 4 by 12. Okay. So for a 12 by 4, 16.8, it's 4 units wide. So it's going to be 2 units from here to here. This is the line x equals 16. So this has to be the line x equals 18. This has to be x equals 14, 2 units halfway. And then this is going to be x equals 15. And this is going to be x equals 17. And things are getting crowded, so I'm going to label X equals 15.5 here. And X equals 16.5 here. So now we know what these lines are. We've got a scale. Eight is your Y coordinate of the red dots. We know that this is at Y equals 8. And it's 12 units high. Halfway is 6 units higher than 8. You could do it. That'd give you. I said you add 6 to 8 and get 6 is 14. And I checked myself by adding 8 and 20. I get 28 and divide it in 2. So that's not 16, that's 14. Duh. Okay. So Y equals 14 here. Then halfway between 8 and 14, you can add 8 and 14, you get 22. Half of that's 11. Or you could say, I know that's 6 units, so this is going to be 3 units. That's going to put it at Y equals 11. Now, notice my line got a little high there. Y equals 11 should be a little lower, but for most of the graph, it's about right. Okay, then this line, which I will correct a little bit, is halfway between 8 and 11. That's going to be Y equals 9.5. Then I'll label these two lines over here. Now you're getting into fractions. This is going to be Y equals 8 3/4. That's this line. And this line, Y equals 8 3/8. You can calculate all that, and you should be able to do the fraction and calculate it. But sometimes when you got really hairy numbers, you just use a calculator. Okay. For these numbers, I say you really should be working with fractions. In any case, there we have it labeled. Now, I'm going to tell you that the formula for a quad shape, 4x4 rectangle, red dot at 0, 0. I've said this before. This formula is Y equals X squared. Since you didn't have sound on that one video where I was talking about this a week ago, I'll repeat it, okay? This shape it's 3 times as high, and the red dot is 16.8. Okay? So for this particular shape, Y is 3 times the quantity X minus 16 squared plus 8. The 3 times as high goes out in front. The 16 is subtracted from X for reasons similar to those that we talked about last time with the X minus 2. And your 8 is tacked on the M. So what you think of is taking Y equals X squared which is your toolkit function. And you move the red dot over 16 units. And that's, we put it here, but then you're going to move it up 8 units. And then you make your rectangle 12 by 4 instead of 4 by 4. So it's 3 times as high. But with the same width. This is a transformation of the toolkit function by stretching it vertically. You understand how if we make the window 3 times as high without making it any wider, it's stretched this way, like stretching a piece of taffy, okay? And we move it over 16 units and up 8 units. We move it over 16 units because to get the same y, x would have to be 16 greater. And we tack on +8. Well, this is y. If we tack another +8 on our previous y value, we're going to end up there. Okay? Make sense? Lost. Something you do, you don't understand why you. Okay? It's one of the reasons we're doing our first couple of weeks the way we're doing it. Because I want you to understand these functions and understand these pictures. Because if you do, a lot of things in calculus and statistics and other things make a whole lot more sense than they would if you didn't. And I think everybody that teaches here, full-time or adjuncts, agrees that transformations are one of the most important things. And if there are 4 things that are really important in this course, one of them is transformations, and maybe it's number 1. You understand transformations, you understand how rates transform. Deep. I could explain it to you right now, but let's wait until we have a little more machinery. Okay? Now, the other thing we can do is the same thing we've done. We can find some clean board space, we'll do it. Oh, look at all that clean board space. Yeah. I'll be glad when my shoulder heals so I can just. I think I could lift this like this, but I don't know. And I'm tired of tweaking that shoulder. So just get it down here where I know it's safe. And now I can do what I need to do. All right, so. Okay, I got. Helped it focus. I can do a table for this graph. Okay, the table's easy. My X values are 14, 15, 16, 17, and 18. My Y values are, make sure, okay, 20, 14, 11. Oh, wait, it's 20, 11. Sorry, looking at the wrong line. 20, 11. I wrote down these numbers too quickly. That 9.5 is going to be there. Okay, 2015, 15 and a half. I forgot 15 and a half, 16, 16 and a half, 17, 18. 1, 2, 3, 4, 5, 6, 7 numbers because we got left edge and right edge and then 5 more lines and we got an X for every one of those, right? So now my numbers are going to behave better, I hope. And I think I get 8 3/4 and I get 8. Then I get 8 3/4, 11, 20. These are from the graph. Calculated, we got y equals 3 times the quantity x minus 16 squared plus 8. So y equals 3 times 14 minus 16 squared plus 8, which is 3 times negative 2 squared plus 8. And can't move this over much further. We're going to tip. But 2 squared is 4. Multiply it by 3, you get 12. 12 and 8 is 20. You can do the arithmetic. Okay? We can complete this table. These numbers are going to match these numbers. So one verbal assignment I'm giving you is finish that. Do that and have that in your notebook. If you're not 100% sure of it, take a picture of it and send me. Okay? Okay. Now, what can we do with this? We can also make estimates. Well, got about 5 minutes left. Incidentally, let me also comment. This building is 4 minutes out of sync with all the other buildings. So I think I'm going to start running class 4 minutes early on that clock, so that we actually start at the time we're supposed to. Okay? How many of you are in favor of that? Okay, most, that's a majority. So yeah, that's what I'm going to do. So next time, get out of the habit of being 4 minutes late, although everybody's usually here 4 minutes early by that clock. Okay? I was wanting to do a little bit of algebra today. So I'm going to measure it. Okay. Now I want to solve. Solve f of x equals 18. What does that mean? Well, your formula is this. Now I can modify this to say y equals f of x, which is 3 times 16 minus x squared. 3 times x minus 16 quantity squared plus 8. That means if I plug a number in for x, I plug the number in for x here. It gives me the y value. Okay. So if I plugged in x equals 17, I would get the y value for x equals 17, which is 11. Well, 17 minus 16 is 1. Square that, we get 1. 3 times 1 is 3, and add that to 8, we get 11. It agrees with the graph. Okay. To solve f of x equals 18 using the graph, first of all, we figure out where 18 is. Here's 14, here's 20. So halfway between 14 and 20 is 17. So y equals 18 is probably about here. That means we have this point, we come down here. I'll say y equals f, so y is approximately 18. X is approximately what? Well, it's between 17 and 18. It's past 17 and a half. It looks like it's about 17.7. Okay. So if you remember what the function was, we can solve that algebraically and see how close we were. How do I solve this equation? Well, a lot of people like to do this. Subtract 8 from both sides, and we get 3 times the quantity x minus 3 squared equals 10. I'll talk more about equation solving, but I'm just giving you a taste of what we're getting into and how the algebra corresponds to what we've learned from the graphs. Okay, so now we do divide by 3. The 3 divides the 3, leaving us x minus 2 squared equals 10 thirds. So that x minus 2 equals plus or minus the square root of 10 thirds. Okay. Now, you might not remember all those steps, or I'm giving you a taste. You should have seen stuff like this, but I'll ease you into it. There's some simple rules that we'll start talking about next time, okay? Like I can add the same thing to both sides. In this case, I add the equation -8 equals -8 to this equation, and I get this because the 8 minus 8 gives me 0, and 18 minus 8 gives me 10, right? I've got 3 times the square equals 10. Well, if I divide both sides by 3, I get this. Now that's pretty obvious. Now, why is x minus 2 equal plus or minus the square root of 10 thirds? I'm not going to explain that right now, but we'll get to it. Okay, but you will get some explanation. We've got a question here. Hopefully I didn't make a mistake. Okay. Fortunately, somebody's more alert than I am. It's x minus 3. I was writing fast. Okay. So when I was writing the square, I just wrote another 2. So that x equals, put some dots in here. We have 3 to both sides. X is 3 plus the square root of 10 thirds. Well, 10 thirds is 3.33. The square root of 3.24 is 1.8. So that's approximately equal to 3 plus or minus 1.8, which is equal to 3 plus 1.8 or 3 minus 1.8, which is equal to 4.8 or 1.2. If you look at the graph, uh-oh. It doesn't match at all, so I did something really stupid. Okay, that's how you don't solve the equation. The solution is a lot like that. How could that possibly be wrong? Oh, I'll have to ponder that. Those are simple steps. So I must be losing my mind. See, I'll probably better get out of here so you don't get hurt.